Hello everyone, welcome to Civil Mania. So in today's lecture, I'll be telling about other options of Risa 3D, such as in my previous video I have told you about units and its settings. So these are the different settings of the model. I will show you. Just let me, as I have shown you the units, now let me show you the info. This is the info page of the project. Now let me go to the settings. As you can see here, this is the total space of this interface, then members space, wall panel space. You can go to the advanced option, and these are all already set by default as the delta value of for earthquake. So these are the various axes. Vertical global axis is set as Y. Even I can change the vertical global axis to other axis. Then default plane, that is the XY plane. Then plate local axis orientation is global. Then these are the code books. Even you can change here the various code books, like for hot rolled steel sections as it is IS 800. Even you can change to the other international codes, or you can change to the IS 800 1998. Then for the connections, this is the code. For the cold formed steel, this is the code, because for both of them the Indian standard code is not present. Then for wood also no Indian standard code is present. Concrete IS 456 2000 is present. So as I have set my country to India, so these are selected by default directly. So for the masonry, American Concrete Institute code, then aluminium, for the aluminium, then structure type is I have kept as building. If I need to design for the bridges, then you have to select the bridges, or else you have to select as buildings. Remember that before doing the designing of the buildings, you have to set it here buildings, or else you have to set it here as bridges. And stainless steel, this one is the code. Then for the concrete, the analysis method is like PCA, load counter method, or exact integration method. Exact integration method. Then for the compressive stress block, this one is the rectangular stress block for the concrete. Then for the rebar column, minimum steel is 1%, column maximum steel is 8%. Even you can keep it as 6%. Wherever it's like in the case, like whenever it is overlapping, then you can keep it as 6%, or else you can keep it as 8%. Then rebar material specifications. Then number of shear reinforcements 4. So these are by default. It has been even you can set as default. You can click on set as default. Then these are the various seismic values. This one is the IS 1893 earthquake resistant design code, selected by default. Seismic zone selected by default as 4. Medium soil type medium, importance factor 1. Then the base elevation, I have to set it during the time of designing. So these are all selected by default. Okay. Now after that, before doing any kind of drawing, we have to set the grid system in a proper manner. Like you need to first go to the drawing tool. As you can see here, this one is the drawing tool. So here you need to go, and as you can see here, 30 grids at the spacing of 0.305 meter, or in the y-axis also 30 at the rate of 0.305. I will set this one as 30 at the rate of 1 and 30 at the rate of 1. So now the grid sizes will change. See, these are my grids. Now the grid sizes are being changed, or I can even keep the instead of 30, or even you can keep in this manner, such as suppose the first one is the 1, then second one is the 2 meter. In this manner also you can keep it. This is how. See, as you can see here, in the x direction I has kept as 1, then this one is the 2, same as like that of the Tekla software. In Tekla structures also you need to define the grids in this manner. or else simply write as 30 at the rate of 1. So 30 grids will be created by default. So 1 each of 1 meter. So this is how we will create the grids first before the construction. Now let me create a beam, and in that beam I will do the analysis as well as designing, and I will show the shear force diagram as well as bending moment diagram and deflections as well. So let me first go to the drawing tool, and I have set this one as the grids as 30 at the rate of 1, 30 at the rate of 1. After that, this one is the plane by default, x and y plane. So now let me go to the home and select on member. Suppose I need to draw a beam. Even I can draw it from here, or I can draw it from any point, such as I have drawn it from here, or I can let me draw it from here by itself. So what is how much? Let me keep the span of the beam as 2 span of first span as 11 and second span of same 11, or keep it as 8. So 8 plus 11, it comes as 19. So this is how I have created. Now you have to simply press the escape button. So this is how I have created. Now you have to switch off the display grids. As you can see here, you need to switch off the display grids in order to check for the beams. But remember that during the time of drawing the beams, these are the various member properties, they were set by default. As I have not changed it here, you can do one thing. You can, during the time of drawing, you can set the member properties, or else you can set the member properties afterwards, such as I will simply click in one of the beam, and such as here label is member 1. This one is the member 1. This one is of 11 meter length. This is a beam. Okay, now let me select the member as what kind of member, whether it is concrete or wood, because it is selected by default as hot rolled steel. I will select the beam as concrete. After selecting the concrete, let me select the material as, suppose I will select the material as M25. Now its size, concrete 254 by 251. Let me change the beam size as the depth as, let me change the depth as 450. Let me change the depth as 450 and width as 400. So this is the beam I have created. So this is the beam I have created. So this one is a one kind of rectangular beam. Even you can select here. Okay, now the design, shear, rebar, design rules, you can even set to the custom values. Then typical rules, even you can set to the custom. Okay, then there are additional properties like N1 and N2. These are the two nodes. This one is the N1 and this one is the N2. Even you can show their nodes by simply going to the view. Sorry, you need to simply go to the drawing tools. You need to simply go to the home, and in the home you can see here, this one is the level. So you can directly click here and you can show the nodes as well as levels. So now it will show you as N1, N2 and N3. So this one I have changed its properties to beam and M25 and concrete. Let me change this one also. This one as beam, then this one is of steel, and this one is created in this manner. So let me now check the 3D view of the figure, and for checking the 3D view of the figure you have to go to the home option and you have to click it here. See wireframe, color code or render option. As you can see here, now you need to press the shift button and middle mouse button. Shift button and middle mouse button. This one is the concrete beam, whereas this one is the steel beam. So in order to if you need to match both these properties, like if you, as I have created one concrete beam and I need to create this beam also as the same material of same property concrete, then as you know that in AutoCAD software also I have taught the MA command, that is match properties command. Similarly here also it's same. So what you need to do is you have to go to the drawing tool, sorry, view, let me check it where you need to go. Yeah, you need to go to the modify. As you can see here, you need to go to the modify tab, and after that you can see here this match, control shift C, you need to click it here. After clicking it here, as I will match this one with this, as you can see here what's it's written, select the members that will be matched, this one, and I will match the member to this one. So I'll click it, see now both the members are changed to the same property. So this is how we can change the property. Now as you can see here, there is a little bit gap present here. By default, what you need to do is you need to simply select any member, then right click it. After right clicking it, you can go to the model view settings. After going to the model view settings, you can go to the members. After going to the members, you can see here percentage of land. If you will increase it to 100%, and after that if you preview it, see both the members are now joined. So this is how you need to go to the members and increase the percentage land. Even you can change their transparency. If you will keep it as 100%, then both the members will become transparent, but I have kept this as opaque. Okay, apply it. Okay, this is how I have changed both the members. So hope it's clear to all of you how to draw the members and how to show their node values and how to draw the beam of same property by using the match command. Now I will go to the home button, and there I will go to the boundary conditions. As you can see here, the boundary conditions. So now I will provide the supports to the beam, and for that what I will do is, let me select the fixed support. These are all created by default, so you don't have to do the modification every time. These are by default, it is created. So simply I need to select create the fixed support in this manner. Then what I'll select the fixed support and I'll click to apply. Now I will apply it here. As you can see here, this one is my fixed support which is created. As you can see here, this one is the fixed support created. After that, let me keep in the middle the pinned or the hinge support. So click on apply it, applied. See, as you can see here from the inside, it's applied. See, it's applied. Now I will apply it here again, the fixed support. So click to apply. Now again applied. So this is how I have applied. I have created the beam. Now I have applied the boundary conditions. After applying the boundary condition, next step is to apply for the load. So what you will do is you will simply go to the home button, and there you will select on the here you will select on the type of load. Suppose I want to create or I want to apply UDL, uniformly distributed load. So it's a one type of line load. I will keep it as line load. Now in which direction I want to apply the load, in y direction, it's okay. Now remember that this one BLC, this one is the load. Okay, so for the load, what you need to do is you can set it here. You need to click it here, and after clicking it here, you can see you can create numerous number of load. Suppose I have selected the first load and I have written their description as the suppose I have selected, I will be creating first the dead load. So I will write the description of the load. Now from the category I will select the type of load. These are the various type of load I can select. So I will first apply the dead load in the one number. So apply it. So this one is the dead load. Now let me write the dead load, its unit. Suppose I will be applying the load of 10 kilonewton. So I will write as minus 10. Remember that always in the downward direction it is negative y-axis. So I will apply the load in minus 10x. So I will be applying minus 10. After that you will be applying for the full length, or you will be applying for the partial length. You have to write down in terms of percentage. So I will suppose I will apply for the full load, then I will apply it. Now active load, click to apply. Now I will apply about this section. This one is the load I have applied UDL. Now press the escape button. After that, next I will again go to home button. I will apply, let me apply as the dead load in this manner, as well as I will apply it here. Suppose this is the dead load. So let me click to the dead load, line load, click to apply. Same thing, I will apply it over here, because dead load is applied in both the portion of the beam. So now let me remember that I have not calculated here the dead load, that is how much the load will be created. Because for calculating, what you need to do is you have to go to the calculator and you have to type as what is the volume of the beam. The volume of the beam is, for this portion it is 11 meter into 0.45 into 0.4, as the beam's space size is of 450 by 400 mm, multiply by 25. So each weight will be 49.5 dead load, whereas each weight will be other. Each weight, the second portion, each weight will be other. So I have not calculated it, I have simply applied it here for showing you how to do the analysis and how to apply the load and how to do the design. So I have applied it. If you want to check both the load, then you need to go it here. After that you need to go to the load, basic load cases, and like as you can see it here, this one is the one load. Even I can go to, to the model view. Let me do one thing, let me in this manner I can check, or just wait. You need to do one thing is you need to simply go to the here. Let me go to the basic load cases. See, there are two distributed load. So for showing both, what you will do is, if I, as it's showing by default, right click in the space, model view settings, go to the load, then after that, as this one is the same type of load. See, you can see here the dead load is present here, but let me do one thing. If I suppose I will be keeping both the load as dead load and dead load 1 and dead load 2, then I could have selected from here the second load, then it would have shown. But as both the loads are similar, so simply cancel it. Let me do one thing, let me select it here, or let me do one thing. In this menu, go to the distributed load. As you can see here, member 1 is having the distributed load of 10 applied to the 100%, as well as member 2 is also, make it as active. So see, now as you can see here, both the load are in a proper active manner. So now both the load are being shown. After that, what we will do is, suppose I will apply the live load over the here and live load be a point load. Then I will apply to the point load in the y direction. I will apply it. Now let me click it here, go to the second load, keep the load as the live load, and let me select the live load as the one kind of. Actually remember that live load is created, though it's created as a area load, but I will create here as a point load, because in structural analysis numericals the beams are created in a different manner. Suppose let me like I will be creating this drawing by considering that it's one of the numerical in structural analysis subject, and then apply as the live load. Then apply live load, click on live load. After that, let me give the live load of minus 20 or no sorry minus 40 kilonewton. Okay, location at, as the beam span is 11 meter, let me keep it as 5 meter. Click to apply. Okay, this one is actually the see, this one is 50%. This one is 1. In terms of percentage, actually you need to set in terms of percentage. Suppose you will keep it as 10. Then this one is the 10% of the full building. So this one is 10. Then 10%, then this one is the 10%, this one is again 10%, this one is 10%. So in this manner you can keep it. Okay, actually I have selected, see, load location or use percentage for a percentage. Suppose I will keep it as at 10 meter. Then in terms of percentage it's better. Yeah, this one is 50%. Okay, click to apply. So I have applied the load of 40 kilonewton at 40%. Now let me go to the distributed load, active. So now it's showing only the, now as you can see here, the 40 kilonewton live load is present here. Now in order to show the dead load as well, what we will do is we will simply right click it, model view settings, load, select the dead load and click on preview. So this one is the dead load, then this one is the live load. So both are being applied. After that you can also even apply the different type of load. Now after that, in the home tab you need to go to the basic load cases. As you can see here, I have applied the dead load and I have applied the live load. I need to now write down the dead load multiplication factor, that is minus of 1, and live load is okay, I don't require it. Now after writing it, just close this one. Now let me go to the load combinations. After that I can also now generate the load combination. Let me click in the load combination generator. As Indian code IS 456 limit state of collapse and limit state of service, I will keep it as limit state of collapse. Generate beam deflection load combinations. Do you want to define the load combinations for the different beams, or it's not required? I will keep it as not required. Do you want to include the rain load? Not required. Do you want to keep the roof live load? You can keep it, but I will not consider it. Now let me in order to continue this one, you need to click it here and you need to click on generate. I have clicked the 2 times, because of that 2 times they are created, so close it. Same thing are created. Now select the 3 and right click it and delete the selected rows. Okay, this one is what it is created. After that close it. After that what you will do is you will either click in this solve or you can click it here, as you can see here. After that click in the solve and you can go to the load combinations deflection 1, envelope only of mark combination or single load combination. Suppose this one is the load combination 1. Now click on solve it. Now it will solve the figure for you. So this one, no strength load combination are selected for design of concrete element. Okay, it's okay, just close it. So this one is what the node reactions are being created for the load combination 1. After that you can also check for the load combination 2. This one is the load, then you can even click it here. After clicking it here you can check for the various results, such as you can check here the load combinations. This one is the deflection diagram 1. Then you can go to this one and you can simply click it here, and after that you can click it here. This one is the diagram. Even you can select with the undeflected shadow. This one is the deflected shape of the beam, or you can click it here. After clicking it here, or you can do one thing, I will tell you what to, because this one is the shear force diagram, it is created by default. Let me click in this button. After clicking in the, as you can see here, the 3 dots are present there, click it. Now let me show some shortcuts here. For that what we will do, let me go to the solutions, load combinations and basic load, add it. Now solve button is not required because it is present at the upper portion. Quick button not required. This one not required. Yeah, this one is required because here in the quick view the view member force is present there. Click it here. Then member color codes not required. Node reactions require. Then wall panel contours, wall panel labels require. Then distance measuring tool is required. Then solid contours require, plate contours requires, plate levels require. Then go to the 3D view. Those are required, so you have to select it here. Selections not required. Modify not required. View, you can add the animate view, save model, window, then drawing tool, display grid. Then you can edit here the display grid. Then advanced, go to the advanced libraries, not require. Then results, you can even show the diaphragm report. Results also not required, so click on OK. Now as you can see here, directly you can go to this option, and after going to this option you can click it here, and after clicking it here, this one is the shear force in the created, which shear force is always created in the y direction. If you want to check for the moment diagram, then bending moment diagram, then you can click in the M/Z. So this one is the bending moment diagram, which one is created. Even you can click in this figure in order to capture the image. See, the full image is being captured. You can now save the file in the PNG format. Okay. This is how keep open after. So this one is the snapshot. You can page sizes later, or in the A4 format also you can save it. resolution you can increase it to 6000 ppi. Okay, so in this manner also you can even the stress number is present here, from then font size is present here, even you can increase their font sizes. Then even you can go to this advanced and Risa logo, you can press it, and all these things you can adjust it. So this is how even we can take the screenshot. Or as I have shown here, this one is the bending moment diagram. Now let me show you the shear force diagram. Then after that these are the two diagrams. Now let me show you the deflection diagram, and for that you will simply click it here, and this one is the deflection diagram. You can simply double click in this line, or you can right click it. After right clicking this, after selecting this line, right click it and result viewer settings. You can go to the result viewer settings. Here the scale, you can also decrease the scale. After decreasing the scale, preview it, see the size is being decreased. You can put to the maximum, preview it. Okay, after that you can also display the load, preview it. So load are being displayed. Along with that they will display the shadow of the deflected model. Otherwise there will be no shadow, means the beam will be removed. This is how. So in this manner you can change the settings. Even in the members you can change it. Okay, member settings you can change it, apply it. Now even you can go to the model view settings. After going to the model view settings, load combinations 1, I am showing the load combinations 1. I can even show you the load combinations 2. Apply it, and for after applying it you can check for the diagram. So this one is the shear force diagram. Then this one is the deflection diagram, but everything are showing for the load combination 1 only. If I need to show for the load combinations 2, this one is the deflected shape of the diagram of the beam with shadow, and in this manner if you want to again go it here, if you want to check the diagram for the load combinations 2, you can go it here. Before going it here or before showing it here, I will even show you two to three things. Suppose such as I have designed the beam, I have shown you here the SFD and BMD from here. Like in this manner I have shown you the SFD and BMD as well. Now even you can go to this explorer, and you can check for the results such as like node loads, point loads. You can click it here for checking the point loads, for nodal loads, then distributed loads, then after that load combinations. So you can check it everything. Then you can even go to the members, and these are the various beam sizes of M25. Then node coordinates, even you can change the node coordinates. Okay, and even you can go to the results part and check for the node reactions. These are the node reactions, these are the node deflections, these are the various member forces at each and every point, member forces. These are the moments value at each and every point, the bending moment diagram, and these are the shear force diagram at each and every point. Okay, so maximum value is maximum value of shear force and maximum value of bending moment at what location it's written here. Maximum is at 0 moment, and minimum is at minimum is minus of 30 at 4.5 meter. Then what are the end reactions, what are the reactions for the beam, this one and this one. So in this manner you can check everything. Okay, so hope it's clear to all of you that how to analyze the beam for the shear force diagram and bending moment diagram, and we can change various kind of properties in this fashion. So hope it's clear to all of you. And even I have not told you about one thing, that is, even you can go to this equal mark and check for the load deflection diagram 2 and check for its values, because this one is the second part. So now let me check for the deflection diagram. Now the deflection diagram is this one. Now let me check for the same is this one, is the same type of deflection diagram. Actually the deflection diagram is also known as the elastic curve. And even you can check for the bending moment diagram, then bending moment diagram, this one, then shear force diagram, about shear force diagram. Even you can check for the load combination, what are the different type of load combination. See, in the first criteria, the diagram and the shear force diagram are created for only the dead load. In the second criteria, that's I am showing it here, it's only created for the live load. And in the third criteria, it will be created for the combination of both the dead load and live load. So let me check for the combination of both. Go to the equal mark and click it, the deflection number 3, solve it. Now it will show the everything for the combinations. Now let me check for the diagram. So this is the bending moment diagram for both dead load and live load, and this one is the shear force diagram for both dead load and live load. So I hope it's clear to all of you. And if you like the video, then please press the like button and share with your friends and colleagues, so that it creates a motivation for me. And if you have not subscribed my channel, then please subscribe it. And thanks for watching my video. Have a great day.